Okay, this is my first video on some math fundamentals, so we'll call this video Math 101, and we're dealing today with properties. So, in math classes in the past, you probably learned about the commutative property, the associative property, reflexive, all these things that you've heard about, but you don't really know what they mean necessarily. So today, we're going to investigate some of these properties because they're going to help us all through algebra. And you're going to have to take algebra for probably, 3 more years, so you might as well learn these properties that are going to apply this entire time. So let's look at one property called the commutative property. So this is called the commutative property. So this we think of as commute, like commuting to work. So that means it can move, right? Commuting to work is your drive to work. So commutative property of addition says A plus B equals B plus A. This is something you've known the whole time, you just haven't really known the name for it. So this is saying that 2 plus 3 is equal to 3 plus 2. And now let's put that in algebra, okay? That means that 2, so this is your first example, this is your second example, 2 plus 3x minus 2 plus 3x minus 9, we can move those anywhere we want as long as we keep that number in front. So this was a minus 9, so we could say minus 9 first. If we want, we can then put the 2 next, the plus 2, and the plus 3x. So we can move anything we want. We could also say 3x minus 9 plus 2, or we could say 3x plus 2 minus 9. Any order, it doesn't matter as long as it's addition. Okay, and this same thing applies for multiplication. So this is the commutative property of addition right here, and now we're going to do the commutative property of multiplication. So this would be the first property, and this would be the second property of commutative. Okay, so this is saying that A times, the dot for times now, is equal to B times A. Okay, what does that mean by example? Okay, that means that, let's use 2 and 3 again. 2 times 3, we know that's 6, right, is equal to 3 times 2. We know that that's 6, so it works. Okay, that means also, so if this is example 1, then example 2 could say that 3x times 2 times y, okay, that can be 2 times 3x times y, okay. It could also be 3x times 2y. You can even put those together and not put the dot in if you want, but there's your dot. But it'd be 3x times 2y. And actually, really, it's good to know that this would be 6xy. Very important thing to notice here, anytime it's squished together like this, this is saying multiplication. So anytime you see this, it's saying that. Okay, so look at this really closely and understand that this means multiplication. Okay, so those are the important things you need to remember, that 2 plus 3 and 3 plus 2 are the same. 2 times 3 and 3 times 2, right? This is, if you think about it, this is 5, this is 5. Everything's all kind of equal here. This is 6 and this is 6. So if this was some number, it would be equal all the way across here. So whatever this would be would match all the way across. So this is your commutative property, okay? A lot of people don't understand that, so when you have something like this, let's say you have a little bit of algebra knowledge, okay? So we go off and we say y equals 5 minus 2x. Well, how do you get that into y equals mx plus b? You use that property that I said that says you can bring this to the front, right? The 2x goes to the front. Let's do red here. Okay, and so it'd be negative 2x plus 5. And that looks more like y equals mx plus b, with this being your m and this being your b. So that's how you're using it. So they'll call this applying. Apply. Okay. You need to use the math or else you'll never really understand it. So one other thing we want to see is how this is going to help us solve equations. So first, now we can rearrange things. We know this right here, very important. When they squish them together, they mean multiplication. Okay, we understand how we can move things around in a equation. What else can we do with this? Second part here. Okay. Now what we want to do is we want to understand multiplicative identity. Okay, so multiplicative identity is what we'll do now, and we'll do additive inverse as well. So multiplicative identity. Okay, ID, your identity is who you are. Identification, it's going to keep its identity. Okay, so your multiplicative identity is saying that if you take some number, we'll say x, and you multiply it by 1, 1 times x is x. It's saying 1 times any number is itself. So here's your examples, okay? What's 1 times 20? It's 20. What's 1 times negative 90? It's negative 90. What's 1 times 2xyz? It's 2xyz. And we can even use the understanding that what's 7x times y times 1, right? And here we can understand that even though the 1 is coming towards the end, it doesn't matter because of our last rule right here, our commutative property. So it doesn't matter that the 1's at the end. It's still going to be 7xy, and we squish them together to show you that that's multiplication. Okay, so that's your multiplicative identity. And your last property for this video is your additive identity. So this stays the same. So what this is saying is if I have something that's equal to 1, let's say I have this equation here, and I divide it by 2, and I divide it by 2. What's 2 divided by 2 equal to? 2 divided by 2 is 1, right? So what this is saying is 1x is equal to whatever 8 divided by 2 is, and that's 4. So it's saying that 1x is 4, so it's saying that x is 4. So now you can look at this and say, oh, I see. It's connecting to all the math I've done before. So that's good. Let's do our last one, additive identity. Additive, or actually we'll do additive, I'd rather do additive inverse. Additive inverse property. All that's saying is that if you take, what's the opposite of it? If you take 2 and then you add negative 2, okay, you're going to get 0. If you take x and then you add negative x, you're going to get 0. In the same way, if you take y and just minus y, you'll get 0. If you take negative 5 and minus, well, now it's got to be the inverse, so instead of a negative, this will now be a positive. This will be the one that will probably catch you, if anything. Okay. Oops, sorry, this is a plus. Because you're adding, okay, so here it is. Take a close look. Our original number was negative 5. We added, because it's additive inverse, added, and this one this one's a little bit different, so keep in mind that this one's a little bit different. Okay. But it's the same idea. So we took this original number and we added the inverse, and this number in this case, the inverse instead of being negative 5 is positive 5. So what's negative 5 plus 5? It's 0 again. So all the way across it's going to be 0. So that's your additive inverse property. So all your additive inverse property is saying is right here, if you wanted to put it in a general form, some number plus the negative of that number, the inverse of that number, will always be 0. Okay, think of it for 5 plus a negative 5 is 0. 5 minus 5 is 0. 100 plus negative 100 is 0. And that's what's going on here.